Hello, and welcome to a thought experiment about Santa and higher spatial dimensions. Let's quickly recap the Santa mythology. At your house, on Christmas Eve, at midnight, Santa arrives in his sled, pulled by 8 flying reindeer, and carrying a bag of toys and gifts. Santa hops out of his sled and onto your roof. He goes down your chimney and into your living room, where he leaves presents under your Christmas tree. He drinks the milk and eats the cookies that you left for him before going back up the chimney. He hops in his sled and leaves before the clock shows 12:01. After Santa delivers all of the presents, he returns to the North Pole, where he lives in a big house with a bunch of elves, where he spends the year making presents for all of the good children. While you're asleep in your bed at your house, he sees you. He sees you while you're awake. He knows when you've been naughty. He knows when you've been nice. He tracks all of this information on a list, which he checks twice. This leaves some unanswered questions. 1. How does Santa visit every house exactly at midnight? In the continental United States alone, there are approximately 100 million houses. He has to visit your house at midnight, but he also has to visit your neighbors, all of the other houses in your city, all of the houses in the neighboring city, all of the houses in the next state, and all of the rest of the houses in the entire country at midnight. One theory is that Santa can use time zones. Because there are 24 time zones, Santa could take up to 24 hours to visit every house in the world. In the continental United States, there are 4 time zones which follow the sun from east to west as the Earth rotates. Eastern time zone is first, followed by Central time zone, then Mountain, and finally Pacific. Each time zone has its own offset, so that when it's midnight Eastern, it's still only 11 p.m. Central, 10 p.m. Mountain, and only 9 p.m. Pacific. This would give Santa an entire hour to visit every house in the Eastern time zone before the clock strikes midnight in the Central time zone. The problem with time zone theory is that there are 25 million houses in each time zone, which means that Santa would only have about 1/10,000th of a second to visit each house, or about the time it takes for your computer to write data to its hard drive. Or for our purposes, nearly instantaneously. 2. How does Santa fit down the chimney? If we look at your house and we look at Santa, we can compare the width of Santa to the width of our chimney, and we can quickly see that Santa is much jollier than the chimney is wide. 3. How do all of the presents fit in the bag? If the average present is 6 inches by 6 inches by 6 inches, that's 216 cubic inches. 216 cubic inches times about 300 million presents equals 68 billion cubic inches of presents to deliver. If we convert this to cubic feet, this would be 37 million cubic feet of presents. This would require a bag 334 feet per side, about the height of a 20-story building on each side. If each present weighs half a pound, the total weight would be 75,000 tons. If a railroad car can carry 150 tons, you would need 500 freight cars. 4. How can Santa watch everyone all the time? If this is your house, and Santa stands around outside your house, unless you're standing in a room with windows, he can't see you. Even if your house has windows on every wall, you could duck or hide behind something. Effectively, Santa must be able to see through walls in order to watch you all the time. Santa must watch other people too. If you knew that Santa was watching your neighbor, for example, he wouldn't be watching you, and you could get away with being naughty while he wasn't looking. With 100 million houses, Santa has to somehow watch all of them all the time. And he has to do all of this while he makes toys at his factory at the North Pole. 5. Where does Santa really live? We say he lives at the North Pole, but there's no landmass at the North Pole. Perhaps his house is built on top of the ice. We're told that when he's done delivering presents, he flies north, but maybe that's the best explanation we have. These are some interesting unanswered questions. As a child, we're told that Santa uses magic. The purpose of this thought exercise is to see how Santa might use extra spatial dimensions to accomplish the same things. What do we mean by spatial dimensions? Our house exists in 3 spatial dimensions. We can measure its height, width, and depth. Each of these is a separate direction that exists at 90 degrees to all of the other directions. And each corresponds to a separate spatial axis that we can use to measure length or position. We can locate every point in 3-dimensional space by specifying its location along each of the 3 spatial axes, x, y, and z. To this, we can add more spatial dimensions, each of which is at a 90-degree angle to all of the others. For each, we need an additional coordinate to specify our location. Back in the 3rd dimension, we can't see or access these extra dimensions. We can't point to them because our bodies, nor any machine we build, is capable of bending in those directions. Effectively, our entire 3-dimensional universe exists at location 0, 0 in 5-dimensional space. To help us visualize this, let's shrink our entire universe down to a single point. We can then visualize our 4th and 5th spatial axes as a plane, and our entire universe exists as a single point on this plane. As we move along either of these axes, we move to a point that represents an entirely separate universe, or perhaps the location of our universe within this 5-dimensional space. Let's see how space-time fits into this model. Space-time is a product of Einstein's relativity, where our 3 spatial dimensions are closely coupled with gravity and time along a 4th-dimensional axis. As we've seen, our house exists in 3-dimensional space, where each dimension can be measured along an independent axis. To understand space-time, let's simplify our model in a specific way. Let's align our view along the z-axis. In this view, we can't see the z-axis because it points toward us from the screen. This is called a 2-dimensional projection. For clarity, let's remove the wall and we can see our man inside the house. Even though this universe exists in 2 dimensions, it still follows the rules and mechanics of a 3-dimensional universe. For example, we would still need 3 coordinates to measure our man's position in space. If we ask him to go climb on top of the fireplace, as he walks toward the fireplace, we see his position change along the x-axis as he walks around the tree, but also along the z-axis as he walks toward the back wall. At first, he appears to be in front of the tree, but now he's behind it. We see that he's moved to the right, and his x position has changed accordingly. As he reaches the back wall, his z position increases, and as he climbs upward, his y position increases. For this next part, for clarity, let's color the wall orange, and let's install a window on the eastern wall. However, you can't see the window from your perspective because it's hidden by the cross-section of the wall. So if we asked our guy to lean out the window, to us it would appear that he can magically crawl through the wall because the hole for the window is obscured from our view along the z-axis. Let's put things back to normal and pull our man out of the window. In our model, time is a separate axis. and we can plot our position along this fourth axis using time itself. If we ask our man to go from the window to stand to the left of the fireplace as he moves, we can track his position in both space and time. Without time, space-time would just be space. There would be no before, no after, and no causality. Everything would happen at the same time, resulting in a jumbled, chaotic reality. Fortunately, we have space-time. Let's further simplify our model and look at three specific time frames. For clarity, let's spread things out. We can disregard the three spatial coordinates, and let's label each time frame. Now let's talk about time travel. Time travel involves accessing the dimension of time as a fourth spatial dimension where you can move people, objects, or information from one point in time to another. Let's say that just as our man reaches the fireplace, he steps on a hidden device. He's lifted out of our reality and teleported back in time to 12 o'clock, where his future self sees his past self just start to turn from the window, and his past self turns from the window to start walking toward the fireplace just in time to see his future self appear out of thin air. If his future self was to warn his past self not to walk to the fireplace, this would result in a time paradox. You see, if he warns himself not to walk to the fireplace, he'll never step on the device which transports him back in time. And if he never travels back in time, he can't warn himself. Meaning, he's destined to walk to the fireplace and be teleported back in time. This means that both of his past selves exist in a state of temporal superposition, where there are now two realities that coexist, and both are equally real. Fortunately, our man decides to say hi instead. However, there is a wrinkle in time travel. Let's say that, as a byproduct of time travel, our man's clothes are now dyed orange. I don't know how time travel works. Maybe that's what happens. So at 12:04, when he steps on the device, he travels back in time to 12, where his clothes become orange. When he reaches his destination, he immediately starts moving forward in time, and as a result, a copy of his future self exists alongside of his past self in each past time frame, up to the point where his past self steps on the device and becomes the time traveler. At first, this seems just like what happens in a time paradox. However, even in a time paradox, the traveler would arrive in the past, then start moving forward through time, so that he would exist in every subsequent time frame. However, since he only traveled back in time in one of the two alternate realities, his future self would only half exist as a time traveler. As the traveler arrives in the past at 12, two important things happen. His past self immediately realizes what's going on and knows that he must exactly repeat the actions of his future self, because if he doesn't, he could create a time paradox. At the same time, his future self recollects what happened at 12:04, which is now in his past, and realizes that if he continues to stand on the time travel device, this will lead to an awkward situation where his past self is waiting for his future self to move out of the way, so that he can complete the actions of his future self by stepping on the device. Thinking quickly, his future self climbs up on the fireplace so that at 12:04 his past self can complete his journey to the fireplace, travel back in time, and eventually become his future self. Our time traveler moves to the past along the time axis, but clever viewers may have noticed that I skipped over an important detail. He actually moved along two axes. If we recall our two-dimensional model of five-dimensional space, our entire three-dimensional universe exists as a single point on the plane described by the fourth and fifth axes. If we label the fourth axis time and plot each of our time frames along this axis, we can plot the course of our time traveler along both axes. First, he moves laterally along the w-axis out of our timeline. Then he moves back along the axis of the timeline. Then he moves down the w-axis and rejoins the timeline. Though it's possible in our thought experiment to eliminate the fifth W-axis and simply travel back in time using only a single axis, we quickly see that this is problematic. If we go back to our model and eliminate the W-axis, and let's color the time traveler green for clarity. Now, we see that as he travels back in time, the traveler must also exist in every time frame until he reaches his destination at 12 o'clock, becomes his future self, and starts to move forward in time. This creates an awkward situation in the middle time frame where three separate copies of him coexist. His past self turns to walk to the fireplace and suddenly sees two copies of himself appear. His future self arrived from the future and is now traveling forward in time. Meanwhile, the traveler is moving backward through time. Since he's moving backward, if he were to say something, the traveler would even appear to move and speak in reverse. Now that we understand extraspatial dimensions and space-time, let's see how these can be used to answer some of our questions. First, how does Santa visit every house exactly at midnight? If this is our house on Christmas Eve, and these are our neighbors' houses at midnight, and we realize that in space-time a copy of all of this also exists at 12:01, Santa arrives at 12, where he goes down the chimney. As he leaves presents, the clock rolls to 12:01, where he emerges from the chimney and then travels back in time, but also moves in space, as he arrives at our neighbor's house exactly at midnight. If we recall the mechanics of single-axis time travel, the traveler is embedded in every time frame between his starting point and destination. Just as space would get jumbled and confusing without time, if we were to be an observer standing outside our house exactly at midnight, obviously we would be wearing night clothes because it's the middle of the night. We would see a stream or streak of Santa as he appears to exist in multiple locations simultaneously. A better explanation is two-axis time travel, where the traveler is lifted out of the timeline along the W-axis and then mysteriously appears at his destination in the past without interacting with his past selves along the way. Santa arrives at our house at midnight, he goes down the chimney. While delivering presents, he and we both move forward in time to 12:01, where Santa emerges from the chimney, then uses two-axis time travel to travel back in time to midnight while traveling in space to the closest neighbor's house. This process continues until he has visited every house. To the observer, Santa appears on every roof simultaneously. Santa goes down the chimney, every chimney. As the clock rolls to 12:01, Santa emerges from every chimney nearly at the same time. And then he appears to disappear as he travels in 5 dimensions back to midnight at your neighbor's house. We can see that two-axis time travel using 5 dimensions is more practical than single-axis time travel using only 4. 2. How does Santa fit down the chimney? Let's recall our 3-dimensional house and its 2-dimensional projection where we can't see the z-axis. We recall that this projection still follows the rules of the 3-dimensional universe, where a man can walk in front of the tree or behind it, or if he leans out the window, he appears to magically crawl through a solid wall. As Santa arrives at your house, we can track his coordinates in space. If we add an extra spatial dimension and its coordinate, we can explain how he can bypass the chimney. If Santa moves to a coordinate along the 4th axis, to a point where the house doesn't exist, he can then move in space to stand at a point in space corresponding to where the fireplace sits. And then back along the 4th axis to our house, where he is now standing in front of the fireplace. To us as observers, he appears on a roof, disappears, we assume, down the chimney, and a few seconds later he appears in front of the fireplace. Although he could bypass the chimney using space-time, this isn't practical. He could simply move forward in time past the point where the house is decrepit and the man inside is old, to a point where the old man is gone and the house is a pile of rubble. He could then move to a point in space to the point in front of the fireplace, which is just a pile of bricks in the future, and then move backward in time past the old man to the present, where he delivers presents. The obvious problem is that the old man in the later time frame would have seen Santa existing both on his chimney and in his living room every day since Santa arrived in the present. Using a fifth axis is much more practical. Again, if we begin with our two-dimensional projection, we can further flatten it out in a new way. We can imagine that our three-dimensional universe is like a playing card sitting on a tabletop. In this view, the x and y axis describe points within our projection. The z-axis still points directly toward us out of the screen. And we add a w-axis that points upward away from the imaginary tabletop. In this view, Santa can travel up along the w-axis, then spatially along the x and y axes to a point in front of the fireplace, and finally back down the w-axis until he reaches his destination in front of the fireplace. From our perspective, he simply appears in his final position. 3. How do all of the presents fit in the bag? As we've seen, Santa's bag would have to be 20 stories tall and weigh 75,000 tons, but obviously that's impractical, and it certainly wouldn't fit in your living room. If we recall that Santa lives and works in a toy factory, and that in our thought exercise he can travel into your living room via a fifth spatial dimension, perhaps he can somehow access his factory using a fifth dimension, and his bag is simply a three-dimensional projection of a five-dimensional machine that allows his toy factory to deliver presents to wherever he happens to be located at the time. In the third dimension, we simply see him pull presents from his bag. 4. How can Santa watch everyone all the time? In our thought experiment, Santa uses a fifth spatial axis to bypass your chimney. From this point of view, your house would appear flat, like a picture laying on a tabletop, and he would be able to see around the walls of your house, just like he would be able to move around them. It's not a far stretch to imagine that he could locate himself at a point along the w-axis where he would be able to see everyone at the same time. 5. Where does Santa really live? When Santa leaves your house after he delivers your presents, he goes north as we perceive it in three-dimensional space. However, it's not a stretch to imagine that he might depart in a direction we don't understand. From our perspective, maybe we just see him slowly shrink out of our existence as he returns home. If his house exists in a fifth spatial dimension, he could build toys all year while keeping an eye on all the children. At this point, we've used extra spatial dimensions to answer all of these questions. Here's a quick recap of the answers. We can use 5 spatial dimensions to explain how Santa visits every house exactly at midnight, how he can walk around chimneys and walls, how he carries around 75,000 tons of presents, and how he can both make toys all year while simultaneously watching all of the children. This concludes our thought experiment about Santa's adventures in the fifth dimension. Thank you for watching, and visit justinpartech.com.